This video covers problem 7.1.076 from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. The problem statement says that we're given two models, R sub 1 and R sub 2, and they're given for revenue in millions of dollars. I think I have too many L's there. I don't know how I did that. Or no, one of those is an I. In millions of dollars for a corporation. Both models are estimates of revenues from 2020 through 2025 with t equals 0 corresponding to 2020. So here's our first model. Notice you've got a constant plus a constant times t plus a constant times t squared. That's just a quadratic function. Since the number in front of the t squared is positive, the graph is a parabola facing up. It's facing up because that's positive. And the other graph, the graph of the second revenue function, is also a parabola facing up. It's just going to be a slightly different parabola because this number is different and the number in front of the t squared is different. The first part of the question asks, which model projects the greater revenue? Is it R sub 1 or R sub 2? And then we're asked, how much more total revenue does that model project over the 6-year period? And then we're asked to round to 3 decimal places. Now, I'm going to show you how to get the answer that WebAssign wants, but I honestly don't think that the answer that WebAssign wants is correct. So I'm going to show you what they are expecting you to do, and then I'm also going to show you how I think you should actually be answering this question and what the actual answer should be. I might be wrong. Please let me know if I'm wrong, but I'm pretty sure that the answer that WebAssign is asking you for is incorrect, but we can still answer and give them the number that they're looking for, and then we'll talk about what's wrong with it and how we might solve that problem instead. Okay, so you've got these two quadratic functions, and the question says, which model projects the greater revenue? Or in other words, if I were to graph these functions, which model has higher y values? Now remember, we're interested in this time interval from 2020 through 2025 with t equals 0 corresponding to 2020. That means t equals 5 must correspond to 2025. So in order to get a sense of what these look like, I want to graph them. We could graph them by hand, but because we've got all these decimals everywhere, I think I'd rather use technology for that. So I'm going to share my screen with you. We're going to use desmos.com in order to graph our functions. So actually I've already done it here, but let's say you go to your browser and you type in desmos.com. And then you'll see this graphing calculator. Say, yes, I want to do that. And it's actually very intuitive. You just type the first function here, y equals 7.21 plus 0.28 times t plus 0.03 times t squared. And if we zoom out a little bit, you see we're looking at a parabola. That's R sub 1, and then R sub 2 is y equals 7.21 plus 0.10 t plus 0.01 t squared. So that's a second parabola. Now again, we're only interested in the part of the parabola or the part of the graph that represents these years from 2020 through 2025. So that's t equals 0 to t equals 5. And if we zoom in, I think we can all see that on the interval from 0 to 5, clearly the red graph is above the blue graph, and the red graph is the graph of that first revenue function, R sub 1. So R sub 1 projects the greater revenue. And if I draw my picture over here on the side, it kind of looks like this. When t equals 0, both of these functions start with a revenue of 7.21. I guess that's like $7.21 million at 2020, probably January of 2020. And R sub 1 looks like this, and R sub 2 looks like this. Okay. And this is the t-axis, the y-axis and the t-axis, and this is t equals 0. Now, the second part of this problem says, how much more total revenue does this model project over the 6-year period? Now, I know what they're asking, or I know what they're expecting, so I'm going to show you what they're expecting you to do, and then I'm going to tell you what's wrong with it. Since we're in 7.1, which is about the area between two curves, and we're saying t equals 0 corresponds to 2020, and t equals 5 corresponds to 2025, to find the answer that WebAssign wants, I think we're just going to calculate that area right there. So you're going to use the top function minus the bottom function, and you will integrate from 0 to 5. And that's going to be the answer that they want, if I'm remembering correctly. So let's work that out, and then we'll talk about what's wrong with that, why that doesn't actually represent the total revenue, or the difference in total revenue that this model projects versus the total revenue that this model projects. That's top function minus bottom function. And the top function was 7.21 plus 0.28 t plus 0.03 t squared. And because I'm running out of space, I'll just make a second integral for the second one. So we're subtracting the integral from 0 to 5 of the second one, which is the integral from 0 to 5 of 7.21 plus 0.10 t plus 0.01 t squared. And we can actually subtract those integrands. I've got this minus this, so this minus this is 0. 0.28 t minus 0.10 t is 0.18 t. And then this minus this is 0.02 times t squared. We're integrating with respect to t. So you want to bring that constant down, then add 1 to the exponent and divide by the new exponent. Then bring this constant down, add 1 to the exponent and divide by the new exponent. And then you want to evaluate that from t equals 0 to t equals 5. This simplifies to 0.09 t squared. This one doesn't simplify as nicely, so I think I'll just leave that one alone. And then if we plug in 5, this is what we get. If we plug in 0, we just get 0. So I have 0.09 times 5 squared, which is 25, plus 0.02 divided by 3 times 5 cubed, which is 125. And they wanted us to round to 3 decimal places. So that's approximately 3.083 million dollars. So that is the value of this integral, which we're interpreting as a difference in total revenue. Now, I have a problem with that. That's the answer that they want, and that's the answer that will get you full credit on this problem on your homework if WebAssign is the one directly grading this for you. And I think what I'm going to do is I'm going to give all of my students full credit for giving WebAssign the answer they want, or typing in the right answer. So let's talk about what's wrong with this. This is a difference in revenue at a certain point in time. If I take this difference in revenue at a certain point in time, that's going to give me, let's say, at t equals 6, we'd have the projected revenue at the beginning of 2026 from this first model, minus the projected revenue at the beginning of 2026 for the second model. So that's going to give me some number of dollars. And then it's going to be some number, and it's going to be some number of millions of dollars actually. And then we're going to multiply by a tiny increment that is in years. So these are going to be dollar years. And we're adding all of those dollar years up to get a certain number of dollar years. So these units really shouldn't be dollars. They should be dollars times years, which is a little odd. That's really not answering the question that they asked us to answer, although this is the answer that they were looking for. So these units are not technically correct. The units should be dollars or millions of dollars times years. And obviously that is not how much more total revenue the first model projects over the second model over the entire 6-year period. And they mentioned a 6-year period. If you're saying to yourself, why 6 years, or why 6 years not rather than 5 years? Let's look at what they said again. They said both models are estimates of revenues from 2020 through 2025. And they want to know how much more total revenue does this model project over the 6-year period starting at the beginning of 2020 and going all the way through to the end of 2025? Well, if t equals 5 corresponds to January 2020, t equals 6 would correspond to January of 2025. Okay, so to answer this question, this is the answer that WebAssign wants. This is the one that WebAssign will like and will give you full credit for. But let's actually answer this question now in a way that makes sense, and we're not giving them some kind of weird dollar years at the end. Okay, gives us a different problem. Here we go. Let's use this part. This is what we should do. Rather than looking at the area between R sub 1 and R sub 2, from t equals 0 to t equals 5, which is what they wanted, or even t equals 0 to t equals 6, which is also tempting because we're talking about from the very beginning of 2020 to the very end of 2025. Rather than calculating this area or this smaller area, which is what they wanted us to calculate. That's what that 3.083 number is. Rather than calculating that, if I actually want the total revenue projected by this first revenue function over the entire 6-year period, I don't want to integrate R1. This is what I want to do. I want to integrate from 0 to 6. So that's from the beginning of 2020 to the end of 2025. And I'm not going to integrate R1, I'm going to integrate R sub 1 prime. So that's the revenue that was accumulated according to R1, that first model. And then if I want to know how much more that model projects than the other model, I have to subtract the projected revenue from the other model. And the projected revenue from the other model is this. This is the total revenue projected by R1 from, let's just say, January of 2020 to December of 2025. And this one is the total revenue projected by R2, by R sub 2, from January of 2020 to December of 2025. And if you're saying to yourself, why the prime? Let's think about it. R sub 1 prime is the instantaneous change in the revenue with respect to time. So this is telling me how much my revenue is increasing per unit time at a particular time. If I plug in T naught here, then it's going to tell me that instantaneous rate of change at T equals T naught. So if I take this and I multiply it by a tiny increment, a tiny change in time, this is giving me a revenue per unit time. This is millions of dollars per year. If I take millions of dollars per year and I multiply them by years, I'm getting a tiny change in revenue, a tiny change in money coming in. That's that increase in revenue over a tiny time interval. And that increase in revenue over that time interval is going to be different from the increase in revenue over the other time intervals because that revenue function R sub 1 is changing. So I need this here, and I take this and I multiply by dt. So this times dt, we can almost think of it as giving us a tiny dr, or a tiny change in r. That's going to give me a change in revenue, and I'm going to add those up from 0 to 6 to get the total revenue accumulated from the beginning of 2020 to the end of 2025. I think when they wrote the problem, when they said, what's the, how much more revenue, where did it go? How much more total revenue does the model project over the 6-year period, referring to the one that projected the greater revenue? And they said 6-year period because that 6-year period is important for solving the problem. I keep showing you work from a different problem there. Okay, so we're going to integrate from 0 to 6 to make sure we capture all of that projected revenue from 2020 to 2025. And rather than integrating R sub 1 minus R sub 2, we're going to integrate R sub 1 prime minus R sub 2 prime. Because the limits of integration are the same. We're integrating both of these with respect to t. So the difference between these two integrals is the integral from 0 to 6 of R sub 1 prime minus R sub 2 prime dt. Now, if you evaluate this, it's not going to give you the answer that WebAssign wants, but I think that the answer that WebAssign wants is wrong, because that gives you some number of millions of dollars per, or it gives you millions of dollars times years, which doesn't actually make any sense. But this is going to give you a change in revenue per unit time times time. So that's going to give me a change in revenue. We're going to add up all the changes in revenue. We're going to get a total change in revenue, or total accumulated revenue we can think of over that time interval. So our functions R sub 1 were 7.21 plus 0.28 plus 0.03 times t squared, and 7.21 plus 0.10 times t plus 0.01 t squared. If I subtract these guys, actually I don't want to subtract these yet. I want to find their derivatives first, and then subtract them. The derivative of R1 is the derivative of this. Derivative of a constant is 0. The derivative of a constant times t is just my constant. The derivative of a constant times t squared is that constant times 2 times t to the 1 less power. Same thing here. Derivative of a constant is 0. The derivative of a constant times t is just the constant. Derivative of this constant times t squared is that constant times 2 times t to the 1 less power. And then if we subtract those, we just subtract in the columns here. We get 0.18 plus 0.04 times t. That's our integrand, and that's what we want to integrate from 0 to 6. Again, it's not going to give you the answer that WebAssign wants, but this is giving you a change in revenue per unit times. It's giving you a total change in revenue for a tiny time interval, and then you add them up, and that's actually going to get you the total difference between the revenue due to this function, or revenue projected by this function, and the revenue projected by this second function, R sub 2. And I might be wrong. Please tell me if I'm wrong about this. I'm completely open to to being wrong. I want to learn. It's okay to make mistakes, like adding extra zeros, like I'm doing right now. The antiderivative of a constant is that constant times t. Bring that 0.04 down, add 1 to the exponent, divide by the new exponent, evaluate from 0 to 6. So we've got our constant times 6 plus this simplifies to 0.02 times 6 squared. And then when you subtract, so that's evaluating at 6. And you also evaluate this at 0 and subtract, but when you plug in 0, you just get 0. So we get that there. And now let's evaluate and see what we get. So I get 1.800 exactly, millions of dollars. That, I believe, is how much more total revenue is projected by our R1 than R2. Now the answer to the question that they are asking, I believe the true answer should be this. But that's actually not the answer that WebAssign is looking for. WebAssign was just asking you to find that area between R sub 1 and R sub 2 over the interval from 0 to 5. So you just identify the top function and bottom function and integrate, but that's not actually going to give you how much more total revenue was projected by the first model than the second. This is actually giving you millions of dollars times years, because that's millions of dollars times years, and that's not what we want. To actually get what we want, we've got to do this instead. That's millions of dollars per year times years, which gives you millions of dollars. And then millions of dollars per year times years, which gives you millions of dollars. And you add up these millions and you add up these millions and then you subtract them to see how much more was brought in by this function, or was projected to be brought in by this revenue function, than was projected to be brought in by this second revenue function, R sub 2. So please feel free to tell me if I'm wrong. I'm happy to learn from my mistakes, and I'm eager to hear your thoughts as well.